A trebuchet is a working mechanism that throws an object or large stones from point A to point B. A trebuchet is like a catapult but differs in that a trebuchet has a sling attached with some counterweight. A trebuchet was used in the medieval times for warlike purposes to get through many obstacles that went through their way. The counterweight consists of many stones or anything that would make it heavy, and they would throw these cows like this little guy. See how he looks sick? Or any other objects to get through anything, such as this castle. They would throw an object, and the arm would sling and would hit the enemy, infiltrating what they needed to get through. A trebuchet was a major weapon used back in the times they ruled.
Yeah.
The width is 46 and the length is 70. We put this vertical stick, it's 145 centimeters. We put these two to hold it in place, and then these two. Zoom in. We put these two sticks to lock it in place. As you can see on both sides, we put them. Then we drill the hole through it, and then we put a metal pipe through it. And we put this stick across, holding all three of them so it won't wobble. To make like a little base for the pouch. And at the end of it, we put this. We drill the hole through here so we can put a little pin. Let me see the pin. We could put the pin through here, and then once the arm is on, we drill the hole through the arm too, so it could hold it in place, and we just lock it like that. Once we're ready to launch, we just pull it. We put some weights. This is the counterweight. We basically put 2 dumbbells, each weighing 15 pounds. We put these 2 sticks to hold it so it won't like fall off. So basically, it could move. I don't know why we would move it. Just stop. That's how we set it up.
Wait.
Okay, stop. Basically, that's how it stays. You got it? 3.
Wait.
2.
Go.
1. Oh, damn.
Alan, get ready. 3, 2, 1.
This is our calculation for our launch. I drew a picture substituting the distance that we got for x and the time. Velocity in the horizontal direction, the v of x is the first step. The equation that I use is x equals v naught t plus 1/2 at squared. And since it's x, you cancel out the second part and you're left with the first part. Then you solve for it. That's what I got. Step 2 is to find the time to reach the maximum height, which is this time divided by 2 is what you get for your maximum height. Time at your maximum height. For your time at maximum height. That's what I got. Step 3, find the velocity in the vertical direction, v of y. V equals Vy plus AT is the formula that I used. So 0 equals Vy plus negative 10, which is gravity, times the seconds, right? Notice that I used the 1.5. V of y equals 19.9 meters per second for my problem. Step 4 is to find the velocity at the angle. I used v squared equals vx squared plus vy squared, and I solved for it, taking the square root and everything, and I got this. Step 5 is the angle. I use this equation, tangent theta equals opposite adjacent. For opposite, I substituted the vy component that I got, the velocity y, and for adjacent, I substituted the v of x. Then you take the tangent, the inverse of tangent, and then you solve for it. I got a weird decimal, so I just rounded off, so it's approximately 83 degrees. Step 6 is to find the maximum height. So to find the maximum height, you're also going to use the time at half of the distance, since your maximum height is at half of the distance. So y, which is trying to find, equals 19.9 times 1.99 seconds plus 1/2 of negative 10, again gravity, 1.99 seconds squared, and I solved for it, and I got y equals 19.8005 meters.